ओके पूरा है ना भी ओके सो लेट्स स्टार्ट और हो रहा है ना फॉर श्योर timer where is the timer okay so let's start today okay let's start today we will going to start from center of symmetry center of symmetry or inversion center I or you can call it COS. So are you able to listen to me properly? Please reply yes, no, type. I'm saying are you able to listen to me? Okay. So according to the definition, it is an imaginary point within the molecule which actually inverts all the parts of the molecule within the molecule, resulting in an equivalent structure. For example, last time we have taken example of PTCl4. PT, this is Cl, Cl, this is Cl, Cl. So if you do this, apply this symmetry element, center of inversion, let's say here. So what will going to happen? This Cl will go this side, and this Cl will go this side. This PT will remain here, and this Cl will go here. This Cl will come here. So if I indicate this with this Cl with 1, 2, 3, and 4. So it will, after the inversion, it will look like PT Cl4 Cl1 2 and Cl3. So this is we are getting after the inversion, we are getting the equivalent structure. Last time we have told we should after applying the symmetry element, we should get the equivalent structure. So this is the point of inversion. One example is that VF3. Let's say the same example last time I have taken, VF3. Let's say this is the point group. So this is the inversion center. So after applying this symmetry element, inversion center, this F will go this side. This will go this side. This will go this side. So how it will look like? It will look like B, F, and F, and F. Now tell me, first one and second one are the equivalent structure? They are not actually. No, they are not. No, they are not. Because after applying the inversion, they don't look same. Yes, that was the first rule of this symmetry and group theory is that if you want to find out any rotational axis or any axis, any operations you are doing, you have to get the equivalent structure. I'm not talking about BF3 will convert into BF4 minus or something. No, here it is about the structure. So this structure here F was there, but after applying the inversion, this F goes here. That is why they are not equivalent structures. So here this point of inversion is present or not? Here this I is not present here in this case, but here we got for this one PTCl4, for this one we got the equivalent structure here. So here I is present, but here I is not present. Okay, next example, the same example last time I have taken water. See, from only 2-3 examples, it is good to learn all the symmetry and group theory this course. So you can correlate all the elements, all the symmetry elements, and all the operations. It will be easier for you guys to understand. So let's draw the correct structure of water again. This is the structure of the water. Okay. Now, if let's say if someone wants to do this point of inversion, this should be, if someone wants to apply this, say I. So I am taking inversion center is here. So what will happen? This H1, H2. This H1 will go this side. This H2 will go this side. So it will look like after the inversion H1, H2. These two will be here. Okay. Which means after the inversion, you are actually not getting the equivalent structure, or they are equivalent. Yeah, they are not equivalent. That is why in water, in this structure, this molecule I is not present, the center of inversion. Let's say take one simple example, IV6. Oh, okay. So here if we wants to apply the center of inversion, let's say at this place. So what will happen? This will go this side, this will come here like this, which means after applying the inversion you will actually get the same structure. Let's say 1 2 3 4 5 6 2 1 6 3 5 4. So they are equivalent. So I is present here. Next, let's say this, we use this swastik sign. This, maybe this is not correct. This should be like this. Okay. So in this case, if you apply, let's say this is your, let's say this is your center of inversion. So what? First, tell me, what do you think? Do you really think here I is present? A, B, I is not present. Tell me which one is correct. I is present. So yes, so I is present. So if you invert, this is your inversion centers, and then what will happen? This point will come here. They will exchange their position, like similarly here. So this I is present here. Next, till now, let's say for which example I'll say, I'll take any simple example. Let's say PTCL, same example. Say PTCL 1 2 3 4. After the inversion, CL 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 CL. So I 2 1 3 4. This is inversion is present here. So you will again reach the 1 2 4. Some I don't know, something happened. Anyway, okay, 1 2 3 4. After the inversion, it is like they will exchange their position. 1 2 4 3 after the inversion. Again, if you apply the inversion, you will reach to its equivalent position. These two are equivalent. So, number of operations required to get the equivalent structure is 2. And till now we have seen that Cn, if center of axis is present, axis of symmetry is present, then you will how many operations you will require to reach the equivalent structure? You will require n. This is the identity, like the equivalent. This is the equivalent structure. This is identity element. So this you have to remember. Cn, for axis of symmetry you require, and if let's say if C2 is there, then you require 2 number of operations to reach the equivalent structure. If let's say C4 is there, then you require 4 operations to reach the equivalent structure. Similarly, Cn, for axis of symmetry you require n number of operations to reach the equivalent structure. For plane of symmetry, you always require 2 operations to reach the equivalent structure. Like AA, let's say I'm now indicating A1, A2. So if this is the plane, what will happen after applying this plane of symmetry? A2 become like this. Then again you have to apply this sigma, this plane of symmetry. You will get A1 and A2. So this is fixed. This is fixed. For plane of symmetry case, you always require 2 number of operations to reach the equivalent structure. And for axis of symmetry, the principal axis of rotation, this n tells you the number of operations you require to reach the equivalent structure. And we have studied inversion center right now, just now. So for inversion center, what do you think? Tell me. How many operations here required to actually get the equivalent structure? Yes, it is 2 actually. This is similar, like not exactly similar, but it is kind of similar to plane of symmetry. We always require 2 operations, and this is also fixed. This is also always fixed. For these 2 cases, you require 2 operations. And here, the principal axis of rotation will tell you the number of operations required to reach the equivalent structure. Anyway, let's move on to the another axis of symmetry, which is symmetry element, which is improper axis of symmetry. So this is we denoted as Fn. So by the number of, like, the kind of operations involved in this improper axis of symmetry is rotation and reflection. Rotation, we know axis of symmetry. Reflection, we know sigma. This plane of symmetry, POS. C and sigma. Combination of these two will lead to the Sn. This improper axis of symmetry. So this is like an imaginary axis passing through a molecule symmetrically rotation about which by some angle followed by perpendicular direction, perpendicular, I would say, this reflection gives the equivalent structure, or I would say equivalent orientation. I supposed to say this is the correct word actually, orientation. Yeah, orientation of molecule is called SN. So whenever I have said equivalent structure, you should consider this as a equivalent orientation of the molecule, because uh, in chemistry this VF3, this is structure. This structure is actually same. This These are two equivalent structures, but these two not are equivalent orientation. So what initially I have said equivalent structure. So correct. I am correcting it now. It is equivalent orientations of the molecule. So this SN work as uh, this plane of symmetry sigma followed by perpendicular rotation Cn, or Cn followed by perpendicular sigma. For example, let's say if you take the example, one example I can give you is that this one. This one. Uh, this example. So if you do this, let's say first apply the axis of symmetry. So here C3, let's say C3 is present. So what will happen? Let's say this will go here and so on. So I'm again drawing this one, because after applying this you should get the equivalent this equivalent orientation of the molecule. This will go here, this will go here, this will go here. Oh, sorry. Anyway, not C3. I have rotated this with C6, I guess. Yes, C6. This is C6 because this 1, 2, 3, 4, 5, 6. So after applying this axis of symmetry C3, this 1 is going here, 2, 3, 4, 5 and 6. And then I have applied this. I am following this one right now. So CN axis of symmetry I have already applied, followed by perpendicular plane of symmetry, sigma. So this was C6, like this was C6, this is C6. So this is your plane now, sigma. So this is your plane here. If you apply sigma here, like this, I should have used this. If you do this, what will happen? This, you will reach to the same structure, orientation of the molecule, sorry. This is your same equivalent orientation of the molecule. See here, for applying the axis of symmetry, you have got this orientation, but this orientation, this, let's say this is A, this is B, this one is C. B and C are not equivalent orientations. If you look closely, this is going from above, this one, but here this C6 is below. But after applying this axis of plane of symmetry, what will happen? This C6 will come up and this will go down. So it will look like this, like 6, 1, 2, 3, 4, 5. So these are two equivalent orientations of the molecule. Equivalent orientation of the molecule. This is how this. So then after this, we can say that after applying C6 and plane of symmetry, you reach to the S6. This is your improper axis of symmetry. But for other cases also, it is like you can see, according to the definition what I have told, it should have from the beginning I have told you that this has reflection, rotation and reflection, these two, axis of symmetry and plane of symmetry. And I have given this example also, in which both axis of symmetry and plane of symmetry was present, but it is not necessary that, let's say CH4, this CH4, this one, this is tetrahedral as we have studied. Let's say I'm drawing it like that, H, H, this is H, this is H. Okay, here if you try to find out, let's say in tetrahedral, this structure, if you try to find out improper axis of symmetry, I would say improper axis of symmetry, IUS. if you try to find out by our definition that it will going to have your have axis of symmetry and plane of symmetry. Here actually in this molecule, here axis of, improper axis of symmetry is present, which is S4. So, so for S4, I'm doing the, it is like I'm doing the back calculation. For this molecule, I know S4 is there, improper axis of symmetry. Then I am try to find out, are there really proper axis of this proper axis of symmetry and plane of symmetry is present or not. So if according to our this previous theory, that explanation definition, it should have C4 and sigma, then you will get this S4. However, in this case we don't have C4. If you really try to find out this molecule, the C4H doesn't have this C4. Still improper axis is present, which means, which leads to the this new definition of, or I would say not the definition, but exception, or that it is not need not necessary that both axis of symmetry and planar symmetry should present there. So for improper axis of symmetry, to be present in a molecule, there is no foundation, or I would say foundation for us for the presence of proper axis of symmetry, proper axis Cn in the molecule. So for C4H case, you have improper axis of symmetry, but C4 axis is not present. Like in our previous class, I have also said that if if axis of symmetry is present, then you will easily find out how many. If you find out one C2 is present, then n number n C2s are present. Similarly, if Cn is there, means proper axis of symmetry, proper axis. One case is that no improper axis is present, Sn may be present if sigma H present, and sigma 2n is also present if sigma H absent. So this I will explain. See, take this example again. This same molecule, BF3 1 2 let's say 3. Again apply C3. Let's say I also make this orientation, this what do you say, coordination, this axis x, let's say z, this is your y. So this is, if you are applying C3, this principal axis of rotation from here, so it should be your C3Z, because this is your BF3, from here you are applying, from here. So this is your Z axis. So after applying the C3Z, you will reach the B3 to 1. And then again, now according to the definition, what should we do? We should apply this sigma perpendicular axis of plane of symmetry. So what should be the perpendicular plane of symmetry? In this case, sigma, this is your perpendicular, this sigma xy. So sigma xy, this is, you'll get the, this orientation will remain same, f3, f1 and f2, which means that C3Z followed by sigma xy should be here, xy. You'll get the S3, improper axis of symmetry. So this molecule, this BF3 has improper axis of symmetry. Okay, next, next water. Water I have given the example, I guess, for this case. No. Okay, let's take our very first example from the first class, water. This is, okay. If you allow, this is your axis C2, 1, 2, 2, 1. Now perpendicular to this axis, perpendicular to this axis, this plane should look like this, like this, like this, right? Like this. So what will happen? Sigma, if you apply, this will go that side. Plane is like mirror. This will go this side. These two. So this water molecule orientation will look like this. H1, H2. It will look like this. Which means after applying C2 and then plane of symmetry, you are supposed to get the equivalent orientation of the molecule. However, this is not the case here. See, look at these two, A and B. They are opposite, like they are not same, they are not equivalent. That is why in water molecule, improper axis of symmetry is not present. IOS is not present in this case. Okay, now we have read about this axis of symmetry. This symmetry element. Let's take some example. First example, C. This one. So C2. This C2 is like this is example. You have to find out how many, like what are the symmetry element are present here. Symmetry element are present here. Present here. This C2 is present here. This C2 is present here. And here from the Z axis C2 is present here. So here three C2s are present here, and no other axis of symmetry is present. So C2 is your principal axis, and two C2s will be your subsidiary axis. So in this case, if you try to find out, now these are the axis of symmetry. Now I try to find out plane of symmetry. So in this case, plane of symmetry is present or not. Let's say this is your axis of symmetry. So perpendicular to this, let's say this is a perpendicular plane. It will reflecting back to it will reflecting the same structure, same orientation of the molecule. Yes, in this case. So here sigma s is also present. Now what is left? Axis of symmetry, plane of symmetry. Now inversion center I. I is present or not? Here, if you look closely, this is too messy now. Yes, you can come back after 2 minutes. Okay. So this is your inversion center. So here, this is present or not? If this is your inversion, this will go that side like that. Okay. So here inversion center is also present. This one. Now what is left? Axis of symmetry, plane of symmetry, inversion center, then improper axis of symmetry. Let's find out improper axis of symmetry. So for Sn, there should be sigma Cn or Cn followed by sigma. So we have C2 axis plus sigma h. Sigma h is also present, which means that the S2 is present, right? C2 followed by sigma h is present, so S2 is present here, axis of symmetry. Now, next example is your benzene. Here, try to find out how many, what are the symmetry elements are present here. So let's say if this is the planar molecule, and here this is your axis of symmetry. So like 1, 2, 3, 4, 5, 6. After applying this axis of symmetry, C6, it will rotate. It will give a structure like this one. 1, 2, 3, 4, 5, 6. So here, in this case, C6 is present. Yeah, okay, you're back. So C6 is present in this case, and as I have already told in my first class, that if C6 is present, you have to find it. If there is any C2 axis present, which means that 6 C2 axis will be there. So if this is your C2 axis, giving the equivalent orientation of the structure, which I have found out one C2 axis, which means there are 6 C2 axes are present. Now, how many sigma v's are present? Like this plane of symmetry are present. So again, take this plane, considering which is having this C2 axis. It will give you the same axis of symmetry, this same molecular orientation of the. So have 6 sigma v's. And if this is your principal axis, perpendicular to that, because it is planar molecule, so sigma h is also present, 1 sigma h. This number you know how to get this number. This I already told you. This you know, sigma h you know. Do you know this how to determine these 6? I think this is I have also told that how to get these 6 number. How many sigma v's will be there? Anyway, here 6 sigma v, 1 sigma h, and this inversion center is also present. This is the center. So this will go here, this will go here, this will go here. You will get the equivalent orientation of the molecule. This is also present. Now let's try to find out there is improper axis is present or not. So here we know this C6 is present and C2 is there. Sigma H is also there, which means that we have improper axis of symmetry S6. This is I have already told you that if Cn is present, then Sn will be present if Sh is present, if sigma H is present. I can show you like this. Like this is sigma. So by applying this, let's say first take this axis of symmetry. Take axis of symmetry C2, and if this is your coordinates Z, X, Y, so this will be C2Z, C26, sorry, C6. This is principal axis of symmetry, C2, C6Z, this. So you'll get 1, 2, 3, 4, 5, 6. You'll get this structure. this one. Then actually we are trying to find out this improper axis is really present or not. Now apply this sigma xy. Sigma xy, this is the plane, this is the plane. So this is present in plane only. You will get the same structure like this. Same orientation of the molecule. 1, 2, 3, 4, 5, 6. Means that you are getting the same orientation, equivalent orientation of the molecule. Means that you are having S6, improper axis of symmetry, which we have learned today. Next example is this one. This CH2, CH, H, CH2. This one. So here, if you look closely, what are the symmetry elements are present? This C2 is present. Okay, C2 is present. If you rotate it like that, and also this sigma B is present. This is the plane. If you cut this plane from the between, or if you put the mirror in between, it will reflect. It will give you the bisect the same molecule, like bisect in two equivalent parts. So you are also having the sigma plane of symmetry, but this plane is containing your principal axis of rotation, which means it is sigma b. Now I try to find out sigma h is present or not. So this was your axis of symmetry. So perpendicular to that, it will be your sigma h. So I don't think that sigma h is present, because if you take this plane, this h will reflect here, this will reflect here, this will reflect. So you will not get equivalent structure. You will get structure like this, h, not a structure, orientation, sorry. This will get like this. So these two are not equivalent orientation of the molecule, which means sigma h is not present. Let's try to find out inversion center is present or not here. Here, what will happen? This will go here, this will go here, h, this will go here, and vice versa. So after applying sigma h, sigma, not sigma h, sigma inversion, you will get C and H, CH2, CH2. So these two, this A and B, are not the equivalent orientation of the molecule, which means that the I is also not present here. Now try to find out, is there SN present or not, improper axis of symmetry. You can simply find out according to our this definition, that SH is present, SN is present, which means that sigma H should be there. However, in one case also, this no sigma H, in case when Sn is not present. Anyway, here in this case sigma H is not present. So we can simply say that Sn is this is absent. Improper axis of symmetry is absent. Or we can try to find out, like we did for other case also. like CH2, CH2HH. This was our molecule, and after applying, let's say, axis of rotation C2, this you will get the same structural orientation CH2H, CH2H, and then you have to find out the this improper axis of symmetry. To find out the sigma, this you should apply this sigma perpendicular to this sigma 2, this C2. So this was your C2 perpendicular to this C2. This is your sigma H. I mean, not for the molecule sigma. I would say is sigma XY if that was Z. So your molecule will look like your molecule will look like this. This. So these two are not equivalent structures. Equivalent orientation. These are not equivalent. So you can say sigma n. This not sigma n. S. Improper axis of symmetry is absent. Now similar to this example, let's tell me now what are the symmetry. Now it's your time. Tell me what are the symmetry element are present. Axis of symmetry, plane of symmetry, center of inversion, and this improper axis of symmetry. Tell me, this is your homework. Not homework, this is your assignment. Are you able to listen to me? Hello. Yes, tell me. Here, what are the symmetry elements are present? Okay, I is present. Yes, I is present. Plane of symmetry, axis of symmetry. See, so I would tell you that whenever if you want to solve any question, you first go with this order. Okay, with this order, it will be easier for you to determine the all the symmetry element. Then, of course, at the end you have to find out the point group of the molecule. So if you follow this order, this first, then second, then third, then fourth, then you will reach to the correct structure, the correct point group of the molecule. So let's say this is axis of symmetry. First you have to find the axis of symmetry. So is there any axis of symmetry you are able to see? That is the question. So let's say this is the axis. Let's say this is planar molecule. In the middle, here, this this place, this place. Here, I am rotating it like this. Let's say like this. So what will happen? This will, let's say I am rotating this anti-clockwise. So what will happen? This will go that side, and this will go that side. So you will get the equivalent orientation of the molecule. Means that you have C2 axis here, because this is going here, this is going here, which means that you are rotating this 180 degree. You are rotating this molecule by 180 degree, which means axis of symmetry is present, which is C2 axis. First one is done. This is present. Okay. Next, this plane of symmetry. So this was your molecule. This was your axis of symmetry. The C2 axis was there. This is your plane. So, and this is planar molecule. So this here plane is also present. This sigma h, because this is your molecule. This is your molecule, and this is your plane perpendicular to this C2 axis, in which this in which all the atoms of the molecule is present. So sigma h is also present, means plane of symmetry is also present. This one is also present, and you have correctly said that inversion center is also present, because here if you pinpoint this point, if you invert from this point, this CH2 will go that side, and this CH will go this side. So basically you will get the equivalent structure, means that I is also present. This one is also present. Next, this improper axis of symmetry. So for improper axis of symmetry, two conditions were needed: sigma h, and then this Cn. So here in our case C2 is there. Sigma h is, we have seen that it is present, which means that the H2 is present. This improper axis of symmetry is present here. Okay, let's take another example of H2O2. This is, I am drawing. Don't think like it is correct. Don't think it is I am drawing correct or not. I am just giving one hypothetical situation that it is like that. It is like that only, because this is the molecule I am proposing. So actually it is not correct. That is why I am saying this. So let's say this molecule is planar. This is given to you. Now if this is planar, then you have to find out what are the symmetry elements are present here. So now you try to find out, like now you tell me, first try to find out axis of symmetry is present or not. C2 is present. Yes, exactly. This is C2. Yes, C2 is present. Now next one is plane of symmetry. Plane of symmetry is there or not? Yes, of course. Sigma is present. C2 sigma h. Now I, inversion center, is there or not? Yes, inversion center is also there. I is also there. Now it's time to find out the SH, this improper axis of symmetry. Yes, S2 is present, because these two are present. It will give you S2. Yes. Nice. Now again, hypothetical situation. Let's say this molecule is again planar, but not in this condition. Let's say in cis condition, in cis conformation. This is trans. Let's say this is cis. Yes. Now tell me, what are the symmetry elements are present here? Axis of symmetry is there or not? First one. So in this case, you are not able to see axis of symmetry, right? But I'm saying this is planar molecule. Okay, this is in your plane. Let's say this is your, yeah, C2 is there here. C2 is there like this. If C2 is going from here, so if you flip it 180, it will like this. This 2 will go here, 1 will go here, they will exchange their position. Of course, they will also exchange their position, 1, 2, 2, 1, 2, 1, 1, 2. So C2 is present, okay. C2 is present. Next is plane of symmetry. Is there any plane present here or not? Yes. So which plane are you able to see? Let's say sigma V, sigma H. Which one are you able to see? Um, Actually, okay, let's how many C2 axes are present here in this case? Only one. If you are saying so, let's say this is your planar molecule and one axis. This is your C2 axis. This is only this C2 axis is present. So sigma H, what represents this H is perpendicular to the this your super axis. So what will be the perpendicular axis? This, not axis, sorry, perpendicular plane. So this is your perpendicular plane. So what will happen then? If if sigma H will be there, then this molecule, this H atom will go here, this atom will go here, these two will remain there. So will it be the equivalent orientation of the molecule? 2, 1. This is sigma. If you like, this is your C2. If you add the plane here, like this is your plane, then this this orientation, your orientation of the molecule will look like this. So sigma H is not present. Sigma H is when sigma H, what sigma H is there? Like, what is the definition of sigma H? Sigma H is the plane which is perpendicular to the principal axis of rotation. So here principal axis of rotation is what? C2. This is your C2. In molecule it is like O, O, H, H. Here only. So, and this is your C2 or principal axis of symmetry. Perpendicular to this. Perpendicular to this, this will be your, or this will be your plane. So it will flip the molecule like this. So these two not are equivalent orientation of the molecule. That is why sigma H is not present. Sigma H is not present. But is there any possibility of sigma V to be present in this molecule? So, so it is, yeah, sigma V is present. Sigma V is here. This is sigma V. This is your sigma V, which is, this is a C2 axis. Now this time, this is your, not, this is not your plane now. This is your plane. This is your plane. One O is here, one O is here. One H is here, one H is here. Now this is your plane. This is your bisecting your H2O2 molecule. So this O will come here, this O will come here, this H will come here, this H will come here. So you will get the equivalent structure. Sorry, orientation. If this is your plane, 1, 2, 1, 1, okay. So 2, 1, 2, 1. After applying the sigma V. So sigma V is present. Okay. Now what is next? I. Tell me, I is present or not in this molecule? No, yes. I is not present. Next, what is next? Fourth number. Improper excess of symmetry. Is present or not? Yes. Because why it is not present? Yes, sigma H is missing. Yes, that is why. Yes. So Sn is not present. Next example. Take this example. H H H H H. Uh, okay, now this is similar to your BF3 molecule. This molecule similar to. Now tell me in this is we have solved, I guess. Now tell me for this molecule, what are the like elements are present? Let's start from the first one, excess of symmetry. C3, yes, C3 is present. Next is plane of symmetry. Okay, sigma H is also there. Yes, sigma H is present. But sigma 3 is present, sigma H is present. But any other axis is present or not? Are you able to find out any? Yeah, C2 like this. C2. These two will interchange position here. These two will remain here. So C2 is present. So okay, according to our first class, whatever I have told, how many? Just now you don't have to find it. Find out how many C2 axes are there. So if you remember the trick last class trick, if you know the proper axis of symmetry, and now one subsidiary axis. So how many C2 axes will be there? Three, yes. So three C2 axes are there. Now plane of symmetry, sigma H is there. Is there any other plane of symmetry present? Means you are saying about sigma D. But before reaching to this sigma D, you have to find out one other thing also, which is sigma V. There is case no. I've told you. I think if you remember or not, if you want to find out, let's say there are multiple plane of symmetries are present, multiple plane of symmetries are present. Then how you can find out which one is sigma D, which one is sigma S, which one is sigma V? Sigma H you know, because it is perpendicular to the this your C3 proper axis, which you have already found out. Now how to say this is sigma D or this plane is sigma V? So if why this is not moving, I guess note is not working. Yeah, now it's working. Okay, so we had few conditions. If sigma h is present, sigma v is present, sigma d is present. Sigma h we know C3, that is the perpendicular plane to the principal axis. So this that you will call as sigma h. If sigma, that was one condition. If sigma h is present, whatever plane of symmetry you will get, whatever plane you get, you cannot say these are sigma d. If this is present, you cannot say these are sigma d. Other planes are sigma d. These will all will be sigma v. So whatever you are plane are getting, whatever you find out, all will be sigma v. So sigma v, this if you this is a plane, let's say. It's very haphazard. So this is your plane. Along with this, your C2 axis, it will cut this molecule into two parts, bisect this molecule into two equivalent parts. This will go here, and this will be, you will get the equivalent orientation of the molecule. So sigma v is present. Sigma v. So how many sigma v's are present now? 3 sigma v's. This I have already told you. Now sigma axis of symmetry is done, plane of symmetry is done. Now it's time for inversion center, I. So do you think I is present? So in this molecule, are you able to find out I? I is there or I is not present? Okay. If you are saying so, I believe you are considering this is your I, right? Point, inversion point, right? But this is your inversion point. Then this H, what will this H will reflect here. This H will reflect this. Yeah. So I is not present. Okay. I is not present. Okay, okay. Probably yes. I think so. Yes, if you actually draw it like this, yeah. If axes are there, let's say this, then this will be your. I think this is the point you are talking about. That is the point, right? I think then you can. No, no, then also. No, no, no. No, no. No, I is not present. Because it is like, no. Let's say this is your point you're talking about, right? So if this is your point, if this is your point, what will happen? I don't think so. No, 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 no chance. No chance. Okay. Next, next what is I? Next fourth one. Fourth one is improper excess of symmetry. Now try to find out improper excess of symmetry. So we have already know that. Yeah, yeah. Tell me. Yes, yes. Yeah, S3 is there. Okay, nice. S3 is there. Nice. Now another example. Cl, 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 Cl. Now tell me first AOS, excess of symmetry. What are the excess are present? C3, yes, C3 is present. Yes, C3, C2s. Sigma H, yes. Sigma V, yes. How many? Sigma V, yes. Really? Now, whatever I can like judge from your responses, that you have understood very well everything, but you are little bit confused in about the I. Ex- Yeah, here I is not present. Look closely. Yeah, maybe. No, not imagination. Maybe this is the first time you are learning. That is why. So, see, if you consider this is the point, then what will happen? Just uh, think like one point. Let's say this is the plane or something. Any book or something I have. See, just consider like this copy. In the copy, you consider only one point. Only one point. Only one point. Let's say this is your point. This is inverting all the atoms of the molecule and giving you the equivalent orientation of the molecule. If that is present, like if it is giving by applying this inversion center, if it is giving the equivalent orientation of the molecule, then I is present. If not, then I is not present. So, in this case, consider this I, this, this is the point. So what will happen? It will invert this, these two will come here. Correct? So, you are not having Cl here in that position, which means like after applying the I, how I'll tell you how it will look. It will look like mm, dish, I, okay, Cl. It will look like this. So do you think these two orientation of the molecule are equivalent? No. So this is the point. So these two orientation are not equivalent. That is why you don't have I in here. I is not present. Now find. Sorry. Yeah. Anyway, I'll solve a lot of examples here. You will understand. Anyway, IUS. Find out IUS. Improper access of symmetry is present or not. Now you can just tell it is present or not. Okay. S3 is present. S3 is present. Yes. Now similar example, but I am changing some positions. These positions. So now it will be little bit tricky, but solvable anyway. HCl, HCl, ClH. Now tell me, what are the excess of symmetries are present? Yes, C3 is there. So you are saying C2 is not there, huh? Okay, C2 is not there. Actually, C2 is not there. Okay, now then of course you have to move to this plane of symmetry POS. Now find out plane of symmetry. Sigma H is not there. Yes, sigma H is not there. Okay, anyway, if if this is, see, sigma 3, C3 was, this was your point, this was your axis at which you are rotating your molecule, right? That is why you got this sigma 3, this, sorry, C3. What is it? Then you got this C3. So if you apply the perpendicular to this, okay, sigma H of molecule. So sigma H is not present, but you are saying sigma V is also you are not able to see. So this was the point at which you are rotating. That is why you got this C3. Now consider this plane. Consider this plane. Right. So this plane will contain this Cl and H, and this portion is similar, like equivalent. So sigma V is present. Now I have told you one sigma V. So now how many sigma V you can find out? Yes, three. Now tell me, in this case, I is present or not? Yes, I is not present. Okay. Then improper access of symmetry. Okay, not present actually. Okay, let's take, let's say, letters from English alphabet. A. Find out access of symmetry. Plane of symmetry. C2 is present, yes. Sigma V is present, yes. I is not present. How many sigma V you are able to find it? Okay, if you consider this plane in which this I am writing, this is also the plane, no? So 2 sigma V, right? Yeah, because sigma S is not present because this is your C2 axis perpendicular to that axis. No, no plane of symmetry is present. So sigma H is not present, but 2 sigma V's are present. Anyway, let's move to next capital letter, this B. Oh, I would write it now. Tell me, AOS, POS, I, IOS. C2, yes. Sigma VS. I is not there. Okay. Okay, I is not there. Yes, I is not there. Okay. How many sigma V? Yeah, two. This is one sigma V, the one, and the second one is in which the same plane in which you are writing capital letter, this capital B. Okay. Now, try to, let's say we will know. Now we have learned all the symmetry elements, symmetry operations, and lot of examples we have done. Now let's draw the flow chart from which we can find out, from which by following that flow chart we will be able to find out the point group of the molecule. That is very important. IMP. So that flow chart is very important, and if you follow this flow chart you will be able to simply find out the point group. So flow chart to find out the point group. Okay, point group. And if you want to read the book, so reference is, now somebody wants to join. Anyway, so reference is F A Cotton. F A Cotton. This is book, very famous book. And if you really want to find out this flow chart, you'll, I think this is in on the page number 56 or something, 56, 60, anyway. Here, this is the reference flow chart. Anyway, I will going to tell you also, but if someone wants to learn the uh, flow chart from the book, this is the book, F.A. Cotton. Or you can, I will also, if you want the book PDF, then I will share on the in the description of the YouTube, also in the material section, like the materials here. I think are you guys able to access my YouTube video and material? Oh, is he left? I think. Oh, one person, one is okay. Tell me, you are able to see my video last week's video and material. Are you able to access my material also? Okay. Oh, okay, no problem. If you want, you have this book, F.A. Cotton. I mean, yeah, PDF. Anyway, I'll share that in material section. Let's move on to this. Okay. So how this flow chart is? This is very important. I think you should note it down. So it will be very easy for you to find out the point group of the molecule. Okay. So let's say group of high symmetry. This is group. So there are three sections. Oh, again. Group of high symmetry. If any molecule is having higher order symmetry, yes, in that case, these molecule will have point group like tetrahedral, octahedral, D infinite, C infinite, H and anyway, let's say, okay. If this group of high symmetry, the molecule is not having like higher order of symmetry, let's say no, then we will move to here. You have to find out the rotational axis is present or not. That we then we define that which one is proper axis, which one is improper axis. Sorry, not improper. Which one is subsidiary axis. And third one is this point group is Sn. Okay. If now in this case, first one is if this axis of rotation is present or not. Let's say yes, it is present. Then we will find the this axis of rotation axis is present. Then we will try to find out the this how many, let's say Cn and is perpendicular to n number of C2s. Let's say if this Cn is not present, this is not present, no. In that condition, the point group of the molecule could be C1, Cs, and Ci. So I am just now I will introduce you. C1 is if any is the any one molecule, let's say C2, you are rotating for two times, so 180 degree. C1 is like you are rotating the molecule by 360 degree. C1 is identity element E. Sigma S. Sigma S is Cs. Sorry, Cs is sigma H. The molecule is planar, but you cannot do any other. I'll give example also. Anyway, C1 is like let's say this molecule. See, C1 is this. This is C1. So you will not find any other symmetry element in this molecule except if you accept identity element or if you rotate this molecule by 130 degree angle, like you are basically doing nothing. So C1 could be present. So this is the example of this one. Anyway, and molecular plane. So this is not actually I have made it, but this is tetrahedral. Any CS molecular plane is present, but this is different. Yeah, let's say BF, in the case of BF3, let's say BF, BCl, and BBr. Let's say this is the example for this one. For this case, if you try to find out the symmetry element in this molecule, there is no symmetry element is present, but molecular plane is present, sigma H. So this is sigma, this C1 is sigma, this is E1 E, and CS is sigma H, and CI is this CI I is inversion. If only inversion center is present. Let's say for CI example is for CI only I is present, right? So example of this one is and like this Cl Cl F F Br Br I is present. Only I is present. No other symmetry element is present. So I is present is here at this position. This is the point of inversion, because at this point this Cl will go here, this Cl will go there. Same applies for these two and these two. Okay. Now, if axis of rotation is not present, then these three could be the possibility for the point group of the molecule. Now, yes, if rotation axis is present, then you have to find out this, that C2 is present or not. That you have to find out, perpendicular C2 with this axis of rotation or proper axis of rotation. So in that condition also, let's say if it is present or not present. No. So if it is present, then you'll get the DN point group. DN point. If not present, then you'll get CN point. Okay. In DN also, if now next, this is the flow chart. You will able to, if you follow this flow chart, if you mug up this flow chart, you will easily find out the point group of the molecule by following the every step. Just okay. Let's see. Sigma H is present or sigma H is not present. So sigma H. So sigma H is, let's say sigma H is present. In that case, then this point group will be DNH. If this sigma H is not present, this is the condition of yes. Let's say no, sigma H is not present. Then we will look for sigma D. We will look for sigma D. Sigma D. Anyway, sigma D is present, yes or no. D and D. DN. If it is present, yes. If it is not present, Dn. Similar to this, Cn. If sigma h is present, yes, or sigma h is not present. If this is present, sigma is then Cnh. And if no, it is not present, then you look for sigma v. Then you look for sigma v. Then sigma v is present, yes. Then Cnv. If no, then Cn, only Cn. So this is the flow chart if you follow this. Now you know this, you will find out because all the symmetry elements you have, all the symmetry elements you know, operations you know, so you will be able to find out this point group. And now talk about this. Tetrahedral you know, octahedral you can easily find out. Difficulty is there, these two. So let's say take one example of C CO2 C triple bond H. In this one C2 is there and lot of C2s like C infinite are there. This is a linear molecule like this. So if you rotate it by, let's say 1 degree angle, you will get the same equivalent structure, equivalent orientation. If you rotate it by 2 degree, then also you will get the same orientation. So like that, if you rotate the molecule in fractions also, like 0.1 degree, you will get the equivalent structure. So that is why this C infinite is present here. This. And C2 is present here in this case. But in this case, only C infinite is present because this is C and here H here. So you are rotating like this. So C infinite. But C2 is not present here because if C2 is there, this H will go there, this N will come here. So C2 is not present. But in this case, C2 is present. Okay, now find out. So C2 is not present. So whatever the flow chart we are following, so not this molecule CO2 is not higher order of symmetry or higher order of symmetry. Higher order of symmetry obviously because you are getting this infinite term. So these two possibilities left because you know CO2 because this is not octahedral, not tetrahedral. So these two is left only, C infinite or D infinite. So for D infinite, we have already seen in this that we have to have for D point group perpendicular C2s from the principal axis of rotation. So in this we have C2 perpendicular to the axis of proper axis of rotation from the principal axis of rotation. So D point group we have D infinite. But here C2 is not present perpendicular to C infinite, means we have C infinite here. So this is the difference. Now try to find out the point group. In D, next we what we look for in D point group. We have reached here till now. We try to see the sigma h. It is present or not. So sigma h, if this is your principal axis of symmetry, this is your principal axis. Then perpendicular to this axis, we have this plane. C will remain there. This is the planar molecules. C will remain there. This is C. O, this O will come there. this O will come here. These two will exchange their position. So H is present, sigma H is present. So if sigma H is present, which means you have this point group D N H, and we already know N, this is infinite, and H. So point group will be D infinite H. But in this case, we don't have C2. Also, if we try to find out the sigma again, for this one, C infinite, here C2 is not present. Now try to find out the sigma H. What is sigma H? Which is perpendicular to this principal axis of rotation. So this is principal axis of rotation. So sigma H should be like this. But what will happen if you put the mirror here? This H and N will exchange their position, which means you will get like this. So these two are not equivalent orientations of the molecule, which means sigma H is not present. And according to what? This is not present? No. We are looking for sigma H. Sigma H is not present. Now sigma V is present or not? So sigma V is this. Sigma V, this plane only, which will contain all this molecule. Like this molecule was H, C, triple bond, N. This is your C infinite, and this is your plane also. In the plane, because this is planar molecule. This is planar molecule. So in the plane, this is your plane. C infinite is this. C infinite is this. In the plane, this is the plane. This is the plane containing the principal axis. So you have sigma V. Means now point group will turn out to be C infinite V. If you have sigma V, yes, then C N V. N we already know, so C N V. Point group will be C N V. This is D infinite H. Other example would be N triple bond C, C triple bond N. So this is C2 present here, C infinite present here, plane, this plane containing the molecule, sigma V is present here, perpendicular to this sigma C infinite, this perpendicular present is plane is also present, sigma H is also present. So C2 is perpendicular to C infinite, means you will get the D infinite H, D infinite, and you have sigma H, means sigma H is present, means your point group will be D infinite H. Now point group, now we will solve lot of questions. Like in the next class, we will try to find out also lot of point groups of the molecule. So let's solve few examples. And after 2-3 examples, we will end this session. Let's say this is the example. Let's say this is the emoticon. Let's say this one. Okay. Now it's your turn. Tell me what is the point group of the molecule? Point group. Tell me the point group of this molecule. What is the point group? Not the molecule, sorry, this emoji. What is the point group? Yeah. Yeah, you follow that thing only. AOS, POS, IOS, and then this flow chart. And then you'll get to know this point group of this emoticon. Try to find out the axis of symmetry. Yes, C2. Any other C2? Any other C2 axis is there? No. Means and yes, okay. Now also no other C2 axis is present, no other axis of symmetry is present, which means that no Cn is perpendicular to C2. This condition is failed. Yes. So if this is not the case, if this is not the case, what point group we will reach to? Cn point group, right? So Cn point group will be there. Cn, okay, and so in our case it is C2. Next, we will try to find out the plane of symmetry. So is there any sigma v is there, right? This is sigma v, right? So sigma v is there. So inversion is not there. This is not there anyway, and sigma h is not present anyway. This is sigma 2, sigma C2 perpendicular to this. This is your perpendicular plane. You will not go. You will not go to the similar equivalent orientation of the emoticon. So sigma h is not there. So that condition is also gone. That this h, this sigma h, this is gone. Yes, no. Sigma v. That is why we are trying to find the v, like the what are the planes which is containing the principal axis of rotation. So C2, this sigma v is present. If sigma v is present, according to our flow chart, this is our flow chart, sigma v. If this is yes, what will be the point group? C and V. Yeah. So it will be, point group will be C2V. This will be your point group. So are you able to follow what I am saying, that how to find out the point group? Okay. Let's see, find out the point group of this emoticon. Yes, C2V only. C2V. Okay. Next example. Now we have, since from the first class, we are seeing this molecule BF3 H2O. Now we have seen all the symmetry elements and operations. We have seen the flowchart of How to find the point group? Now it's time to find the point group of this molecule. What is the point group? Tell me. Now you tell me point group of this molecule. Simply follow the procedure. What is the point group? D2H. D3. Yes, D3H. This is correct. This is correct. Okay, next example. This. Yes, D3H. Next example. Okay, let's try this one also. And this one. This one. Yes, C2H. Now, point group of this molecule, water. Yes, C2. Next, I. F, F, F. And this one is F. Tell me, point group. C4? C4V. Yeah, C4V. It is correct. Okay, so I am ending the session now. Join again on Sunday 4 p.m. Last time too many people were there. Now this time only you have attended full class. I don't know. People are not liking it or anyway. Anything specific you want to cover in this class? Want to be covered? So you are saying you are suggesting that the assignment problems I need to solve. So these questions are from assignments, right? Okay, okay. Next class we will solve the assignments. Okay, no problem. Okay, next exam join on Sunday 4 p.m. We will solve this. Now we will solve the question answer assignments, all the assignments, whatever you have got till now, and your problems also. So join on Sunday. Okay. Now I am ending this session. Okay. Bye.